Process improvements. Grid separation detection scheme. This is automation case study 9. This is an invention I did in Jamaica way back around 1992 to 93 time frame at the Jamaica Public Service. My disclaimer: I was never a system controller or dispatcher at the JPS or anywhere else. I am not an electrical power engineer. I do not claim that I am an expert on the power grid. My training and expertise are in these fields of engineering: industrial controls, SCADA, telecommunications, computer hardware, software, database, cybersecurity, etc. I made a proposal to design and build a system to detect when there is a grid separation on the power grid in Jamaica around 1993. I drew up a high-level block diagram and offered a quotation. I was working as a contractor in the System Control Center when I heard that there was a grid separation. Grid separation is also called islanding or system separation. So here was an opportunity to build a custom solution. To my knowledge, there was no system or instrumentation available that could detect when a grid separation occurs back in 1993. If a system existed, the JPS would have purchased it. I did some research on grid separation, and I found this article on the IEEE's website. I drew up a block diagram similar to what is shown here. It had these boxes pointing to some point, central point, and an alarm is raised, detection is done for a grid separation, but I did not explain the design philosophy or theory of operation, so that was not disclosed. I spoke with an engineer at the JPS head office in New Kingston about my proposal. From the discussions we had, I gather that he consulted with engineers in the US, and they all believed that my proposal was not workable. They believed that the grid separation detection could not be done automatically. I conceptualized and architected the solution 100%. Nothing was built or tested. It was based purely on my theories, my training, and extensive experience. Here is an illustration of an electric power distribution network. Here you have your generator, your transmission lines, your distribution lines, transformers, and your local drop to the end user, like residential customers or businesses. Here's another example of the power transmission system or electric grid. On the top are pictures to illustrate what the grid looks like: generators, transmission, and distribution. On the bottom is the same system but displayed diagrammatically. Those are electrical symbols on the bottom. In this presentation, we'll be looking at what is on the left, that is transmission. Since I am not an expert on the power grid or in managing a power grid, I have made up this hypothetical electric power grid, and this is for illustration. Here is some more information from the IEEE's website on grid separation or islanding. Here is an illustration of a electrical power system with generators, transformers, circuit breakers, transmission lines, and distribution with some load connected. This is hypothetical. So in this scenario, suppose the breaker shown is tripped. You would have generators on the left, and your distribution and load will be working fine. But on the right, you will also have generators and your load, and everything is working okay because the generators can handle the load both on the left side and on the right, even though the circuit breaker shown is open. This is a grid separation or islanding scenario. Arguments surrounding grid separation. Grid separation can go unnoticed. The indicator lamps may be blown. There may be no power outages, and no alarms are raised, and nobody's complaining for a blackout because everything is working. You can also have a SCADA I/O point that is not reporting. There are many reasons why a point is not giving you the correct indication that the breaker is open. In this scenario on the right, the load has exceeded what those two generators on top can supply. So this generator goes offline in the black. When that happens, other generators can trip. In this scenario is a total blackout on the right. Here is a total blackout on the right because there is a grid separation and the system controller or dispatcher is not aware. In this scenario, there is no grid separation, no islanding. This is just a localized blackout or an outage. People and systems are in place to prevent a total blackout on the power grid. This is my best attempt to explain system separation or grid separation or islanding, since I am not the expert. I hope I got it right. Protect your business with automation.